Hello and welcome to the fifth video of the root finding method series. In this video, we'll start learning about the methods from the open category of the root finding methods. As mentioned in one of the previous videos, open methods typically require only a single starting value or two starting values that do not necessarily bracket the root. In the bracketing methods, the two values of the interval must bracket the root. That's why we ran the incremental search to narrow down intervals of a function containing the roots. The open methods, when converge, do so in a much faster way than the bracketing methods. In this video, we'll look at a simple fixed point iteration methods from the open category of the root finding methods. In the fixed point iteration method, we rearrange the equation f of x equals 0 to x is equal to gx. Then we start with an initial guess of the root value and then use the rearranged equation and the initial guess to find the next estimate. Then we repeat the process until a stopping criterion is met. The fixed point iteration function requires the original function, the rearranged function, start and end of the evaluation interval, stopping criterion, and maximum number of iterations as arguments. Since a function can have multiple roots, we first use the incremental search to find how many roots are present. Then we provide initial guesses. If a user-specified initial guess is not available, we use the intervals obtained from the incremental search to obtain an initial guess of each root. In the main while loop, the root is then estimated using the rearrange function equation. We compute the relative error, and if the maximum number of iterations has not reached, we assign the estimated value to x underscore r underscore old variable and repeat the process of estimating new root and continue the process until a stopping criterion is met. Let's now run the fixed point iteration method on the same quadratic function that we used in the previous videos of this series. Here, in both cases, the method converges to the same root and failed to find both solutions at x is equal to 2 and x is equal to 5. In the next video, we'll look at a more accurate and faster method, which is Newton-Raphson method. Thanks for watching and see you in the next video.